Hello class, this is the video for section 2.7 and it talks about combining functions. The following are our learning objectives. Okay, we want to find the sums, the differences, products, and quotients of functions, and then also composite functions and the application of composite functions. So if we have two functions, we can find the sum, the difference, the products, and then also the quotient of that, and then also their respective domains. So if we have two functions, say f, okay, the functions f and then g, okay, we can form new functions, say f plus g, or f minus g, f times g, and then f divided by g. In a manner to have the way we will add, we'll subtract, multiply, and divide real numbers, just like that. For example, we can define a function f of x, okay, by saying that f plus a g, by saying that is what f plus g, okay, and then this is f of x plus the g of x. Now, I wanted to note that this is not the same as saying that we are distributing the function because function is a name. Okay, so if you have f of x plus a y, we don't write this as what f of x, okay, plus f of y, because the f is a name, it's not a number that you can distribute over. Okay. Now, so if the domain of f of a function f is say a, and the domain of the another function say g is what is b. So the question is, if we get a domain, if I find a sum or the difference or the product or the quotient, how do you find the domain of the resulting function? Say the sum, for example. And so it is going to be the domain that is a intersection, okay, this symbol, okay, means that intersection. That is the values of x that is common to both what domains of the function f and the domain of the function what g. Okay, and we apply the same to what the difference, the product, and then the quotient. Except that for the quotient, of course, when you have the quotient, you do not want what the g of x, okay, your g function to be equal to what? Equal to 0. Because it becomes a rational function where the denominator cannot be 0, or it cannot divide by 0. Okay, so algebraically, if you define the function f and g, any function, it could be, one could be linear, the other will be quadratic, or whatever the functions are. We can always find their sum, their difference, their product, and then the quotient. And then, of course, as we have defined before, f plus g of x is the same as what the f of x plus the g of x, and their domain is what? A intersection what? Intersection b. The same for the difference and the same for the product, except that when we come to the quotient, you do not want the denominator, you don't want to divide by what? Divide by 0. Okay, so s belongs to what? Both the intersection, what is common to both the domains of the individual functions. Okay, so let's take an example where we are given that f of x is 1 over x minus 2, and the g of x is square root of what? X. Okay, now individually, we know that if you want to find the domain of, say, the f, you can tell that it cannot be equal to 2. X cannot be equal to 2. It could be everything except what? 2, because if x is 2, you have for 1, you're dividing it by 0. Okay, and then for that of g, we know it's going to be what? X must be what? Greater than equal to what? Equal to 0. All right, so let us start with we want to find the sum, the difference, and then the quotient, and then also find their domains. Okay, so we want to start with the first. We want to find the domain of f of x. F of x, as I explained, because if you have 1 over x minus 2, okay, your denominator, s is take it and set it to 0, and your s is equal to what? It's equal to 2. So you're saying that x for the domain cannot equal what? 0, because if it equal to 2, it's equal to 2, and if x is equal to 2, then you have what? You're divided by 0. You're going to have something like this, which is what? Undefined. Okay. So the domain of G is what? Greater than or equal to 0, as explained. Then what's their intersection? Okay, the intersection of the what? The domain, that is all x for the f except for 2, and then greater than or equal to 0. That will tell you that anything to the what? If you combine the 2, it belongs to both of them. It cannot be anything to the left. It cannot be negative or less than what? 0. So it has to include 0 to 2, and then from 2 to what? To positive infinity. So that would be the combination of the domain when we were of these two functions, f and the g. So now let us find the various functions. So as we said, this is f of x, f of f plus g of s is equal to f of x plus what? G of x. And that is equal to the 1 over, because that's your f of x, and then plus your g, which is square root of that. Now, what's the domain? Again, like we explained, the domain of that, the g must be greater than or equal to 0, and it's not equal to, x cannot be equal to what? 2. Okay, so the combination of that is that if you write in an interval notation, this would be from what? From 0 to 2, and 2 cannot, and then from 2 to what? 2 to positive what? Infinity. Okay, now we can do the same for the difference. This is the sum, and that is the difference. Okay, so again, what we have is that this will be the 1, f of x is 1 over x minus 2, then plus the g, g of x is what? Is x, actually it's negative, so negative subtracting. Okay, so it's not plus. Okay, this is what? Minus. Okay, what's the domain is going to be the same as what? As the first one. And then what is the product? F times g of f of x, which is f of x times the g of x. Okay, this will be 1 over x minus 2 times the g of x. Now we can write as a, like, multiply two fractions, which is mean that the numerators multiply across 1 times square root of x is what? Square root of x, and then the whole of this, x minus 2 times 1 is also what? X minus 2. Okay, now what's the, again, the domain of the numerator, it's greater than or equal to 0, and s cannot be equal to 2 for the function f. And then if you combine it, you get the same what? The same domain. Now, when it comes to the difference, all right, when it comes to difference, this is what? F is 1 over, okay, x minus 2, and then we are dividing this whole thing by what? G of x, which is square root of x over 1. Now, like we are dividing fractions, this will be 1 over x minus 2, then times 1 over the square root of x. And so this becomes the whole function, which is 1 over x minus 2 times the square root of 4x. Now, what's their domain? Now, this time, because the square root is the denominator, it cannot equal to, s cannot equal to 0, because if x is equal to 0, you're going to have 0 times negative 2, which is undefined. So that is why this domain, you don't have what? If you look at this, x is greater than or equal to 0, but here it's just what? Just greater than 0. So the domain of this case will be parentheses from 0 to 2, the union 2 to what? Positive infinity. If we write it as what? Interval notation. Okay, so that is why we exclude the 0, because the g of 0 is what? Is equal to 0, and we cannot divide by 0. Okay, so now let's find when we have a specific value, it says for each of these values exists, okay, the values is because x is equal to 4, is in the domain of each of the functions. So if it is not, then we cannot evaluate it at all. Okay, so what is f of 4? Now, where this again, what is our f of x? It is 1 over our x minus 2. And then g of x is the square root of what? X. Okay, so if x is 4, then this becomes, this is the sum is 1 over 4 minus 2, then plus the g of x, which is the square root of 4. And this will give us 1 over 2 plus square root of 2, which is 4 is 2. So this is be 5 over 2. Okay. All right. And that gives us the answer, which is 5 over 2. Okay. Like that. Now let's find the difference also. The difference is the same, but this time is minus. So you get 1 over 4 minus 2 minus the square root of 4. So this gives us 1 over 2 minus 2, which will give us this over 1. That is a negative 1/1/2. And that would give us negative 3 over 2. Okay. And that is why I have that answer, 3 over 2. Negative, actually. Okay, negative 3 over 2. And that will be our answer. Now let's find the product at x is equal to positive 4. Okay, now again, this is 1 over 4 minus 2. And we multiply this by the square root of 4. Okay, which we got when we simplify it, we had what? It was to be negative 4, square root of 4 divided by 4 minus 2. And that will give us 2 over 2, which is what? Which is 1. And that is why I have the answer to be what? To be 1. And then finally, the quotient. Okay, if you remember the quotient, the f of f divided by g of f of x, we got this expression, which was 1 over x minus 2 times the square root of 4x. So we're going to write this as 1 over 4 minus 2, then times the square root of 4. Okay, that gives us this. This is 2 times 2, which is what? 1/4. So we got that as an answer. Okay, now when it comes to sums, you find the sum, the difference, the product, the quotient. We can graphically, okay, add a function or subtract a function. And what happens? Now look at this. This is f plus g. Now f plus g is the output. So on the x and y axis, that is your y value. All right. So what that means is that I just have to add, because this expression is f of x plus g of what? X. For the same input, we input it in f and get an output, say 2, and when we put in a g and get an output of what? 1. So when you combine it, that would be the output of f plus g. That would be what? 2 plus 1. So that would be 3. So basically what we have is that we add the output together to get the third the new function f plus g. And it's similar for, you do a similar thing for x minus g. In that case, you subtract the y values, and that's your output values. If it's multiplying, multiply the output values, and then if it's dividing, you divide the output values to get your answer. Okay, so graphically, if you have this, all right, let's say if you have for f plus g, and let's say our f is this function, the red, and then the g is that. So on the graph, what happens? Okay, how do we add the graph to find the new function f plus g? Okay, so we obtain the graph of this by graphically adding the value of f of x to g of x, as I said. Okay, so this is your, if on this graph, on the f, this is your f of x, that's your output. And then on the g, this is the value of g. So that is what as the output. So basically, if you add this portion, to that of what the g of x, the output, you get the new function for the sum. Okay. All right. So the y values changes, but the input value is the same for both functions. All right. So this is implemented by copying the line segment of PG on top of what PR to obtain the point S on the graph of what F plus G. Now, our next objective function is sort of our learning objectives will find the composite word functions. Now, the composite functions happens when you have, say, a production line, and we have more than one machine. Okay, you give it an input, and the output becomes an input for the next machine, and it processes it and then brings you the final output. So if you have a series of them, if you go to Tesla, you're going to have a lot of, processes from one point to the next, and then finally we get a new car, a nice Tesla car. Okay, so that is a composite function because each of the machines has its own performance and what they do. And they are not the same. But if the first machine finishes its work, it gives you to the second machine, which uses that as its input and gives what. But if you have the process that combine, one process that combines all of them, that's what we call the composite of all the machines. So in this case, we want to define this is a machine diagram, okay, where your h of x is the combination we call is f of g, okay. So in this case, this gives us use the g first, and then its output becomes the input for the f. Now we will call the g of x, okay, inside function, and then we'll call the f of x outside function. Okay, so in this case, what we see here is that this is the final output, and then the g of x, which is this expression. All right, and then this is your x gives it, and this becomes the output g of x, and the f takes it and gives you what, and gives you that. Okay, so if I can tell my f, basically in this case is the square root of x, where my g of x is is equal to this x squared plus 1. Okay, so quick example, if x is equal to say 1, okay, then I have 1 squared plus 1, which is 2, and then the f takes that 2. Okay, so this becomes the square root of 2, and then my output will be square root of 2. See that? Okay, now formally, given two functions f and g, the composite function, which is that, also called the composition of f and g, is defined by this. That is your inner function, okay, inner function or inside function. All right, it's your g of x, and then the outer function is what? Is f. Now we call this sometimes for short, instead of saying composite f composed with f g, or maybe g composed with f, we say that this is simply f of g. So if you hear me say f of g, what I mean is it's not f times g. Okay, it's not f times g, and it is saying that f composed with g. So let me make that distinction, that if I have f of g, all right, f composed with g is not the same as saying that f of g times f of g of x. Okay, f of x times g of x is not the same. They are not the same. All right. Now we can find a domain of this function. This is also using the mapping the arrow diagram for the same function, the composite function f of g, or f composed with g. All right. So like I said, this is the input. That's your domain. Okay, for your domain for the g of x, and then the f takes the output of g of x and then brings out the final output. So basically this becomes the domain of what? Of the f, and it's also the range of what? Of the g. Okay, all right. But to find the domain of f of g is a set of all x in the domain of g, which is the inside function. Okay, such that the g is in the domain of f. In other words, f of g of x is defined whenever both what? G of x, that's the inside function, okay, inside function, and your resulting function are what? Are defined. Okay, now I cannot put this in some steps for you. That fine, this is for f composed with what? G. All right. Okay, the inside function is this. Is in this case my inside function. Okay, inside function is my g of x, and then my outer function. Okay, outside function or outer function is the outside. Let's be consistent with that. Outside function will be your what? F of x. All right. So the domain first was the domain of what? The inside function. So you find the domain of the inside function, and then you look at your final output. That is when you compose f with what? G, and then find the domain of that, and then find what is common between the two. Now, if I give you this one, f of g of f, that is g composed with f of that, this is the same as g f of x. All right. So in this case, this is my f is my inside function. Okay, and then the g will be your what? Outside, or sometimes we can say simply your outer function. Okay, the inside and outer, the inner and outer, or the outside, inner, inside, and what? Outside. Okay. Oh, sorry. Okay, so we can go with inner, either inside or inner function, or outside, inner, or what? Outer. Okay, so this is this, or this is what? Outer. So that means the same thing. All right, so now let's take example, finding the domain of, and this is your homework, similar to your homework question number 15. Find the composite function and then what? And the domain. All right, so here we come with f of x is 1 over the square root of x, and the g of x is x squared minus 9x. Okay, so first let's find these functions. F composed with g, and then g composed with what? F, and their domains. Okay. Now we know that first we have the first one. We have f composed with g, which is f inside. Wherever we see f, we plug in what? The g of x. Okay, so this is basically 1 over, because my f of x is 1 over square root of x, this will be the square root of what? G of x. And that gives us 1 over the square root of the g of x, which is that. So that'll be x squared minus 9x. Okay, now if I want to find the domain, this is your f of g of x. That's your composite function. Okay, now what's the domain? First, what's the domain of f? So let's do domain. Let's use D for domain. Domain of what? The g, the inside function or the inner function, g. We know that this is what? All real numbers. Okay, because this is a polynomial function or it's a linear function, so it's all real numbers. Now, what's the domain? What is the domain of, okay, the domain of our final function, that is f composed with what? G of x. Okay, now that means that we should take this guy, because in the denominator, it cannot be 0. So we have to solve the inequality. X squared minus 9x greater than what? Greater than 0, not greater than or equal to 0. Okay, now this is where we first factor this. You factor x, you get x minus 9. Just set it to 0. And so forth. Just you want to know the values of what x, okay, in that inequality. So you have what x is equal to what, 0, and then x is equal to 9. Okay, so then you have a number line where this is 0 and this is 9. Okay, and then want to test. So let's pick a test value. All right, a test value for this interval. To the left of 0, let's say is what, -1, and to the right of 0, let's put say 1, and then let's put 10 for that, and then test it on what, this inequality here. All right, so let's go. Well, when x is -1, you have what? If even you use this one, you have -1, that's a square, and then minus 9 minus 1. Okay, so you have 1 minus 9, which is 10, which is greater than 0. So this part is true. Then let's pick 1. You are going to have 1 minus 9, which is what? Which is not true. So this is false. And if you pick 10, 10 squared is what? 100. Okay, 10 squared, you have what? X squared minus 9x. So if x is 10, you get 10 squared minus 9 times 10. So you get 100 minus 90, which is 10, which is greater than 0. So that's also true. Okay, so the domain of this function is what? Everything from -infinity to 0, and from what? 9 to what? Positive infinity. Now, if we combine, okay, the domain of the inner function, which is that, all real numbers, and the domain of the resulting composite function, which is that. Okay, therefore, what is the domain of this function? So the domain of our composite function f of g of x, as we just got, okay, which is 1 over the square root of what? X squared minus 9x, is what? From -infinity to 0, and from 9 to what? Positive infinity. Because if you include all other, apart from this, if you include any interval between 0 and then 9, the denominator will be what? 0, which is undefined. Okay, so now let's also find the other one, the g composed with f. Okay, so now our inner function is that. Okay, our inner function is f of x. All right, so this is equal to the g of x, which is what do you call it? X squared. So you have f of x, x squared minus 9 times x. So we're going to prove what? F of x there. Okay, so this gives us what is f of x? F of x is 1 over the square root of what? X. And it said that because the g is x squared, we square that, and then we get 9 times 1 over the square root of what? X. Now if I square the 1 is 1. If I square square root of x, I get x. So minus 9 times the square root of x, which is the same as 9 over the square root of x. All right, so now let's find the domain. First, look at the domain. The domain of the f, because that's your inner function now. Domain of the f is that it is what? X is greater than what? 0. Because it's 1 over square root of x is greater than 0. Or you can say that from 0 to what? Positive infinity. Now, what is the second? What's the domain of our composite function g composed with f, as we found? Okay, this domain also x, if you write in the set notation form, x is not equal to, cannot equal to 0, okay, and x is what, greater than what, 0, for this expression here, okay. It cannot equal to 0 because of 1 over x, and then it is greater than 0 because of 1 over square root of what, x. So if you combine this, all right, it cannot equal to 0. If you talk about negative, it won't satisfy this expression, 1 over square root of x. So domain will just be what, greater than what, 0. So this is the same as saying that from 0 to what, positive infinity. Okay, so to find the domain of a function, a composite function, okay, first find the domain of your inner function or the inside function, and then you find the domain of your result and then combine the domains or find the intersection, what is common to both. Okay, and that's what we just did. All right, now, so we have this part B of the question says that we should evaluate this at f of g. Okay, we remember our f composed with g. Okay, we got 1 over the square root of what, x squared minus 9x. Okay, and then the g composed with f. Okay, we also had 1 over x minus 9 over the square root of 4x. All right, so if x is equal to 1, so the negative 1, this gives us 1 over the square root of minus 1 squared. You see that I'm putting that in parentheses, minus 9 times minus 1, which will give us 1 over the square root of negative 1 squared is 1. The minus 9 times the negative will give you positive 9. So this is basically 1 over the square root of 10. And that will be what we can simplify this. So that would be the answer. Or if you want to change it to radical, you multiply the top by square root of 10 and divided by square root of 10. And that gives you the square root of 10. And then square root of 10 times square root of 10 is 10. So either you have 1 over square root of 10 or square root of 10 over 10, which is the same thing. Now, for the other one, which is this expression, this composite function, when x is 5, that gives us 1 over x, and the x is 5, then minus 9 over the square root of what? Square root of 5. All right. Well, if you want to simplify this, then you want to multiply the numerator. So there'll be 1 over 5 times square root of 5 over square root of 5 minus, then you multiply the 9 by 5 and divided by 5 times square root of 5. So that gives us root 5. Okay, that's to be root 5 minus 45 divided by 5 root what? Root 5. Okay, and so we get that expression. We can simplify it. Now, generally, we want to say that f composed with g is never equal to g composed with what? F. G composed with F. Okay, this only happens, okay, f of g will only be equal to the g composed with F if they are what? Inverses. Okay, if the f and g are inverses of what? Are inverse functions of each other. Okay, which we'll talk about in the next section. All right. All right, so now we can have composite function involving 3 or more functions. Okay, it is possible. So you can have f composed with g composed with what? H. Okay, We do that by applying the H first, then G, and then what? F follows. So we'll say apply H first, second G, and then what? Your F. So we have this expression, f of x is x minus 9, g of x is square root of x, and the h of x is that. Okay, so if you want to find this composite function that involving 3 functions or has 3 machines, what will be the final output? Well, let's try it. Let's find this one. This is f. Okay, f for g. All right, and then whatever we see the g, we plug in what? H of x, which is what? X is h of x, which is x squared. Okay, so that gives us a f of g. Wherever we see g, we're going to plug in x squared. So that's the square root of what? X squared. And that gives us f of what? F of x. Now, wherever we see f, we plug in x, which is the same as what? X minus 9. And that'll be your answer. So this is similar to homework number 16. All right. So composite functions, so far we have used word composite to build what? Complicated functions from simpler ones. Okay. We can also decompose, because in calculus, we should be able to decompose the composite function or the complicated function into simpler ones. Okay, so for example, if you have a capital F of x is equal to the 4th root of x plus 9, and I want us to find the simpler functions f and g such that your capital F of f is a composition of f with what? With g. Okay, so in this case, if I look at this function here, I notice that, okay, this is the inner function. So what does this mean? This is a f of 4, g of x. There, so this is my inner function. Therefore, my g of x, the simpler one, will be x plus what? 9. And then my outside function, the f, in this case will be f of x will just be the 4th root of what? 4th root of what? Oh, sorry. That is equal to the 4th root of x. All right. So wherever we see x, now let us compose and see if we get the same answers. If we use this simpler one to get the composite function f composed with g. All right. So let's do that. So f of g of x. So wherever we see f, we plug in the g of x, which is x plus what? Plus 9. All right. We know that the f is what? The 4th root of x. So we are plugging in what? The g of x, like this, which is the 4th root of x plus what? Plus 9. Okay. So now compare this. This is the same as the capital function, f of capital F of x. All right. So now, finally, we want to look at some applications. So when working with functions that model real-life situations, we name the variables using letters, all right, that suggest the quantity being modeled. So now not to confuse with the f of x and that we want to. So if it is involving time and volume and distance, so we want to use t for time, d for distance, and v for volume, and so on. For example, if air is being pumped into a balloon, okay, then the radius r of the balloon is a function of the volume v of air pumped into the balloon. Say r equals f of the v. Okay, also we know that the volume v changes with time. And so we can also express as a function of what? T. So finally, your r, okay, which is a composition of what? F with g, in this case, will be what? Will be in terms of t. So let's pick a specific example, which is example 7 in the textbook. A ship is traveling at 20 miles per hour, which is parallel to a straight seashore line or shoreline. The ship is 5 miles from the shore. It passes a lighthouse at noon. So express the distance S between the lighthouse and the ship as a function of d, the distance, and the distance the ship has traveled since noon. That is, find f so that your s is a function of what? D. That's f. That'll be your f. Okay. We're using f in this case because we have been saying f of g or f composed with g and that kind of thing. That's what we are doing. I'm using the f and the g in this case. For b, it said express d as a function of t, the time elapsed since noon. That means we want to find g so that the t, the distance, is a function of t. And then we also will find the composite function f composed with g, and then we tell what that represents. Okay. Now, we need to draw a diagram. Going back, he says that the ship is traveling what? 20 miles per hour. That is a rate. And so if I want to find the distance, that's a speed. It's going to be the speed times what? Times time. Okay. But it says that that would be for part B. All right. But the ship is what? 5 miles from the shore. Okay. So this is the shore. If you look at the diagram, this is my shore. And the ship is traveling parallel to the shore. So it means that if it's parallel, it means that if I draw this line, if I join them, that will be a perpendicular. This would be perpendicular to that. Okay. So if it's a perpendicular, this would be the one side of a rectangle, triangle, and this would be the hypotenuse of that. So we're going to have, this is perpendicular to this. Okay. And then you have that. This is 5 miles. 5 miles here. And this is your S. Okay. That's your distance. This is where the ship is. And this is where the shore. Okay. Like that. Okay. So if I use the Pythagoras theorem, or yes, Pythagorean theorem. So by the Pythagorean, okay, theorem. All right. We know that the hypotenuse, square of the hypotenuse, which is the S in this case, is equal to the sum of squares. So that'll be 5 squared plus the d squared. All right. So this, if you take square root on both sides, all right, then we have S is equal to 25 plus the d squared, taking the square root of that. Okay, so that gives us the distance, all right, which is from the lighthouse to where the ship is. Okay, so we go to the next slide to find why we got this. So we can relate the distances S and the D, that is being traveled by the what do you call it? The ship. Okay. And then we got this function. So your S is what? The f of d, which is given as this. All right. And then part B, it says that since the ship is traveling at this rate, okay, distance d is the rate times the time. Okay. And then the rate, which in this case is the speed, all right, the speed times time. And we are using t for time, and the speed is 20 miles per hour. So that gives me the 20 times what? Times time, giving us this expression here. All right. So now we want to find the composite function of that. Okay. Knowing that our f of what? F of d is the square root of what? 25 plus d squared. And then my g of t is 20 what? 20t. So basically, I want to find this as a f of t, which means that wherever we see the d in what? In the function f, we plug in the g of t. Okay. So this is basically where we see that we're going to plug in what? 20t into the function f of t. So that gives us the square root of the 25 plus the d squared, which is 20t all squared. Okay, so if I want to simplify that, then that would be the square root of what? 25. 20 squared is what? 400. And then what? T squared. Now, what does this represent? Okay. What does this expression that we just got? Okay. This composite function, f composed with g, gives the distance of the ship from the lighthouse as a function of what? As a function of time. Okay. So in the nutshell, we have sums, combining function, the sum, the difference, the product, and then the quotient, and find their domains. We also talked about the composite functions and their domains, and then we did some applications. So I hope this helps, and I will see you in the next video. Thank you.